In chemistry, the collision theory provides an explanation of why certain chemical reactions take place, and also why the rates of these reactions is different depending on which reaction is taking place. Good day everyone, we are the group 2 and we are here to discuss about the collision theory. Let's start it off with a short motivation with the saying that life is a series of collisions with the future. It is not the sum of what has been, but what we yearn to be. Collision theory states that for a reaction to take place, reactants must collide properly. The rate of reaction is equal to the frequency of collisions. Collision theory is limited to gases because frequencies of atomic collisions can only be calculated accurately with gases. Collision theory was first introduced by Max Strauss in 1916 and William Lewis in 1918 to try to account for the magnitudes of rate constants in terms of the frequency of molecular collisions, the collisional energy, and the relative orientations of the molecules involved in the collision. So they found that for a chemical reaction to occur, the molecules had to collide, and also there had to be enough energy for the reaction to proceed.
We are going to tackle collision theory generally first, for you guys to have a basic idea on what is this topic all about. According to LibreText Chemistry, collision theory explains why different reactions occur at different rates. Basically, it offers ideas as to why different reactions happen, with each reaction happening in a different time. It also suggests that particles, referring to atoms and molecules, must collide with one another to form reactions. Hence the name collision. Collision theory also states that the rate of the reaction depends on the frequency of collisions, meaning the more the particles collide, the more that they are likely to react with each other and a faster rate of reaction. This theory can be broken down into three key points. First, particles must collide to react. Second, particles must have sufficient energy for reaction to occur. And third, which is the last, is that particles must have proper orientation when colliding with each other.
These are the specific concept of collision theory. Number 1. Particles must collide with each other in order to have a reaction. The collision theory states that a chemical reaction can only occur between particles when they collide or hit each other. According to collision theory, molecules must collide with one another in order to react. The fundamentals of collisions are illustrated in the game of pool. Pool is one of the most well-liked versions of billiards. If the cue ball strikes a stationary billiard ball straight on, then the cue ball will stop moving after the collision. After they collide, they will bounce off with one another and it will have transferred all of its kinetic energy to the other ball, which will move forward with the same velocity that the cue ball had before the collision. A change in temperature affects the reaction in the collision of particles. Question: how does temperature affect collision theory? Increasing the temperature makes molecules move faster, increasing the frequency of collisions. The collision theory says reactions occur when molecules collide with a certain minimum kinetic energy. Since temperature is the average kinetic energy of the particles, most reactions will often occur faster as the temperature rises. Molecules are more likely to have enough activation energy for the reaction to take place when they have higher kinetic energy.
Why particles must collide with sufficient energy to form a successful product. First, we must remember that collision theory stated that for chemical reaction to occur, the reacting particles must collide with one another. That means molecules must collide before they can react. And for successful collision, molecules must collide with sufficient energy together with correct orientation. So back to the question, we can answer that by in order for existing bonds to create new bonds for the product, the reaction must have enough activation energy. And by activation energy, we mean by activation energy is the minimum amount of energy needed by the reacting particles in any particular reaction for that reaction to take place. The activation energy of reactants plays an important role to start a chemical reaction. Bonds between reactants must be broken which are then reassembled into products by forming new bonds, which requires energy. And the energy which is required to break those chemical bonds in reactants is called the activation energy. So to understand more on why activation energy is needed in starting a chemical reaction, we will base our example by this GIF. In order for a large rock to roll down the hill, the person must put enough energy to get the rock over the bump. And also, the catalyst is the one who reduces the amount of activation energy needed for the reaction. As we all have things called catalysts, which are substances that controls the energy needed for a reaction to occur without being consumed in the process. As the description says, it works by lowering the activation energy needed by providing a different pathway for reactions, which in return provides more room for more successful reactions.
Now, let's move on to the third key concept of the collision theory in which particles must collide with the correct orientation. If the orientation of particles is not correct during a collision, the reaction does not occur. The correct orientation is that which ensures direct contact between the molecules involved in the breaking and forming of bonds. To explain this, consider two diatomic molecules AA and BB to give two molecules of AB. There. These two diatomic molecules can collide in many different orientations, but let's just consider the two orientations here. In orientation 1, the two diatomic molecules A2 and B2 are in the correct orientation to react, while in orientation 2, they are not, so no reaction occurs. By this time, you should be able to understand this key concept of the collision theory. Bear in mind that even if the molecules collide with sufficient speed, if they aren't at the correct angle, a reaction would not take place.
Collision theory scenario. Scenario number 1. The bowler bowls a fastball down the middle of the pitch. The batsman takes a mighty swing and totally misses the ball. Scenario number 2. The bowler bowls an off-speed delivery and the batsman checks his swing. The batsman just barely makes contact with the ball, and it dribbles down in front of the batsman's feet into foul territory. Scenario number 3. The bowler bowls a curve ball that looks like it might catch the outside corner of the pitch. The batsman swings with all his strength, but the bat grazes the underside of the ball. The ball skews off to the right, flying into the crowd. The umpire signals a foul ball. Scenario number 4. The bowler bowls another pace delivery down the middle of the pitch. The batsman swings and wallops the ball high into the air, and the ball clears the center field wall that reads 410 feet. The umpire signals a 6. In the picture below, the cricket bat represents reactant A, and the cricket ball represents reactant B. A reaction will only be successful if the batter hits a boundary. If the batter does not hit a boundary, the reaction will be considered a failure.
Next, we have the importance of collision theory. The importance of collision theory is that it explains how to increase reaction rates. It helps us influence the rate of reaction by changing how often molecules collide and their average energy. An example is billiard balls during a game of pool. Billiard balls collide with each other similarly to the gas particles in the box of air. The cue ball must strike the billiard ball with proper orientation and energy to get that ball into the pocket. Mathematical equations are utilized to create rate equations by examining all the elements that lead to more collisions. The factors that cause more crashes have an impact on reaction times. To efficiently produce required products, one must be able to gauge and control the rate of reaction.
In summary, collision theory states that for a reaction to take place, reactants must collide properly. It has three main components. Particles must collide to react, particles must have sufficient energy for reactions to occur, and particles must have proper orientation when colliding with each other. The minimum amount of energy needed for a reaction to take place is called the activation energy. And lastly, temperature and collision of particles are directly related. And that brings us to the end of our presentation. Thank you for listening.